Okay, the next type of graphs are cardioids. Cardioids. So they look like hearts. So if you have the type that has a sine value, I mean a sine function, you have r equals a plus a sine theta, plus minus. You could also have minus. Or you can have r equals a plus minus a cosine theta. So again, if you have a function with sine, you're going to have symmetry with respect to the vertical axis. So your graphs are going to look like a heart that is with the cusp pointing up. So if it's a plus, the cusp is going to point up. If it's a minus, the cusp is going to point down. And these are supposed to be somewhat heart-shaped. Not really, but also the distance from the point that goes through the pole and the point that's furthest out, that's going to be a distance of 2a. And also the distance between the pole and the point that touches the horizontal axis, that's also a. So again, remember that if it's sine, you're going to have symmetry with respect to the vertical axis. And if you have, if it's cosine, then you're going to have symmetry with respect to the horizontal axis. So if you have a plus, your cusp is going to point to the right. If you have a minus, your cusp is going to point to the left. So you're going to have, so if it's a cosine, you're going to have symmetry with respect to the horizontal axis. Okay, so this is the general shape of the cardioids. So let's try an example. All right, let's say I gave you r equals 2 plus 2 sine theta. So right away you know it's a cardioid because these two values are the same. Okay, you know you're going to have symmetry with respect to the vertical axis. So vertical axis symmetry. And so let's look at the helper graph. So I always want you to start with a helper graph, at least while we begin to get to know these graphs. All right, so we have r equals 2 plus 2 sine theta, and I have y equals 2 sine theta plus 2. It's the same graph, right? I'm shifting up 2 units. My max would have been 2, but now it's 4. Would have been negative 2, but now it's 0. And then the period has not changed. So then my graph starts at equilibrium, goes to the max, equilibrium, minimum equilibrium. Okay, so then on the polar axis, I should have at least 4 rings. Oh, here's 1, 2, 3, and 4. Okay, so pretend that these are all evenly spaced. So 0, 2, that means at 0 degrees or radians, I am at the second ring. Then at pi over 2, I'm at the fourth ring. Then at pi, I'm back at 2. See, notice that this distance is A and A. Okay, and then I'm at the origin at 3 pi over 2. I'm sorry, the pole, and then back to 2. So this is what my graph looks like. So I know the general shape. I know that, look, between 0 and pi over 2, the radius is increasing. Between pi over 2 and pi, it's decreasing. And then it keeps decreasing, and that's how we get the heart-shaped. Okay. All right, so far so good. Vertical axis symmetry. Looks like how we want it to look. Okay, let's try another example. R equals, excuse me. Let's try R equals, let's do one with a minus and with a cosine. 3 minus 3 cosine theta. Okay, so I can probably do this without a helper graph now that I kind of know how this goes. So I'm going to need at least 6 rings. And I know it's a cosine, so horizontal axis symmetry. I know my A value is 3. So, and I know these cardioids hit the origin. Okay, these let me use. They hit the origin, and then they go A one way, A units the other way. I know it's a minus, so it's going to point left. And I know I'm going to go out 6, 1, 2, 3, 4, 5, 6 rings out furthest from the origin. So my graph is going to look like this. Okay, so I don't really need a helper graph anymore because now I know the properties and where all these come from. Don't make it so like, it's not really heart-shaped. It's more like, well, it's heart-shaped, but more like an actual human heart, really. So it's a little bit rounder. Okay, so at the pi over force, it really hits, like it goes out a little bit more. If you're worried about, it's looking a little bit more like more accurate, try to go out at the pi over force a little bit more. Okay. So now I know what this graph looks like. Now I can probably graph without a helper graph. But the helper graphs are very useful for these. Okay, the end of this part.